Okay, so let's talk about factoring first, and then the chi function.
Okay.
All right, so normally, like in the regular integers that you knew about before today, how would you factor a number? I'll just make something up. 250.
Well, 250 equals, it's 2 to the 1 times 5 cubed.
Okay. And what's special about this factorization?
Well, you can't use any different
Any other positive
any other
integers.
Positive integers to make 250.
That's right. So this is, and he talks about this, and it actually becomes important. Other than the fact that you can multiply by -1 if you want a couple of times. So you could say this is -2 times 5 times -5 times 5.
Yeah.
So other than sprinkling in some -1s, and you would always need an even number of -1s, this is a unique factorization. So you can definitely say that in terms of factoring over the integers, 250 is not equal to 3 times anything. There's no other way to factor this.
Yeah, into primes.
Into primes, right? And that's a very important fact about integers, that they have a unique factorization. And it turns out that you also have a unique factorization using Gaussian integers. So what are Gaussian integers?
So those are any integers, sort of like, you can think of them sort of like lattice points in the complex plane.
That's right, you can think of them as either being lattice points in the complex plane, or numbers of what?
So
They could write in what form?
A plus bi, where a and b are integers.
A plus bi, where a and b are integers.
Yeah.
Huh? And there are such things as primes here. But not all primes that we know before stay being primes. 3 prime.
5 is not, though.
5 can be factored in this setting. How?
It's 2 plus I times 2 minus I.
2 plus I times 2 minus I.
Yeah.
And he went through a really interesting example to figure out all the ways that you can find a lattice point if the radius is the square root of n. So he gave an example where n was 25.
Yeah.
Okay, how do we find the lattice points here? What do we do?
We factor n.
Okay, so n is, first we might say it's 5 times 5.
And then we have to factor it into the we can factor it, if we can factor it further, we can.
We
Okay.
can factor it in the Gaussian primes.
Alright, so how does this factor in the Gaussian primes?
It's 2 plus n times 2 minus n.
Or 2 plus I times 2 minus I.
2 plus I times 2 minus I. And then it's squared. So.
The whole thing squared, yeah.
Yeah, so this factor, so n equals 25 factors into 2 plus I squared times 2 minus I squared.
Yeah.
And that gives us lots of interesting choices for how to determine the lattice points that are on here.
Yeah.
So what's one lattice point that you know is definitely on this square root of 25 radius
Like,
circle?
The point, like 0, 5, the point up here.
Okay. 0, 5 is on it for sure. What else? What's another point that's on it for sure?
Negative 5, 0.
Okay.
And 3, 4.
Well, let's say them not just as lattice points, but also as complex
Alright,
numbers.
3 plus 4i.
3 plus 4i. So that's a high up one here. Anything else?
Let's see, we have 0 minus 5i.
0 minus 5, which would be just minus 5i.
Yeah.
Good.
And then 4 plus 3i.
Oh, 4 plus 3i.
And then any rotations of these two.
Yeah, and then you can do rotations. And all of this comes from this factorization, which is amazing. Plus, this time around, we don't just have to be able to sprinkle in -1s, but what else can we sprinkle in?
I's.
and negative i's.
I's, minus i's. So we can multiply by -1 I. But here I'm multiplying by these numbers. Why did you say rotations?
Well, that's like multiplying by I in the complex plane is just like rotating.
Yeah, so that's a really cool fact. And he shows you in the video exactly how you create all these, and it basically relates to you have 2 columns. You have 4 numbers, 2 plus I, 2 plus I, 2 minus I, 2 minus I, that you have to put in these 2 columns. And you have how many ways to do that?
So
You have to put 2 in each column.
So you have
you can do both 2 plus i's in this column.
Right, you can put the 2 plus I, 2 plus I.
so there's
You could
8 ways to do it.
You can put 2 plus I, 2 minus I.
You can put 2 plus I and 2 minus I.
And you can do 2 minus I, 2 minus I.
You can do 2 minus I and 2 minus I. That's right.
All
So
right.
how many ways are there to do it?
3.
3. Why did you say 8?
Because I was looking at it like these were different things.
Oh, okay.
They're the same thing.
Yeah, they're the same. So 2 minus I, 2 minus I. These are distinguishable from each other.
Mm-hmm.
So it turned out there were 3 ways to do it, and that comes into play in this last part of the proof. So this is cool. So yesterday when we watched the first 10 minutes, it was a little bit mysterious about how you would determine how many lattice points were part of this,
Or even why we were using the Gaussian integers.
or why we were using the Gaussian integers. But
No,
it
it makes
turned
sense.
out to be related. All right, let's talk about the chi function.
Okay.